Imagine a whisper traveling across billions of light years, a signal that emerges from the dark silence of the cosmos and touches the edges of our understanding. It's not a voice, not a light, not a conventional message we can decode with our familiar senses. Yet it exists, a phenomenon recorded by the most sensitive instruments humanity has ever built. A signal so perplexing that even the most seasoned astronomers and physicists hesitate to name it. The question that immediately arises is deceptively simple. What is it? And why does it matter that we are listening at all? The universe is vast beyond comprehension, a cosmic ocean of matter and energy, where time itself behaves differently depending on where you are and how fast you are moving. In this infinite expanse, detecting a singular, anomalous signal is like hearing a single drop of water ripple in the middle of a stormy sea. But this signal, sometimes referred to as a fast radio burst or FRB, is unlike anything we have encountered before. It is not merely a curiosity. It is a challenge to our understanding of physics, biology, and even the limits of human perception. Consider the brain for a moment, your own internal cosmos. Neurons firing in intricate networks, electrical signals bouncing along axons, chemical messengers crossing synapses with impeccable timing. Your mind perceives reality not as it exists, but as it is filtered through this complex adaptive system. Just as astronomers tune their radio telescopes to detect faint cosmic pulses, your brain tunes itself to pick up patterns, to distinguish signal from noise. When we detect a signal from space that defies immediate explanation, it is not only an astronomical event. It is a mirror reflecting our own perceptual limitations. How does the brain decide that a pattern is meaningful? How do we, as thinking organisms, interpret something that exists far beyond our sensory and conceptual reach? The mystery of a cosmic signal invites us to explore the boundaries of cognition and perception, revealing that curiosity itself is a fundamental mechanism for survival. Fast radio bursts were first discovered in 2007, though one anomalous signal had been recorded earlier, misfiled and almost forgotten. They last for milliseconds, yet in that brief instant, they release more energy than the sun emits in an entire day. Imagine a neuron firing in your cortex, a spike of electrical activity that allows you to recognize a face, understand a thought, or experience a memory. The FRBs, in a sense, the universe's neuron firing across vast intergalactic distances, an electrical pulse that challenges our temporal and spatial intuition. Some FRBs repeat, others do not, and some seem to follow patterns we have yet to decode. Are these natural phenomena, the death cries of collapsing stars or magnetars with magnetic fields a trillion times stronger than Earth's? Or could they be artificial messages sent by civilizations that exist far beyond our comprehension? The mere act of posing such a question transforms the signal from a technical anomaly into a profound philosophical puzzle. It forces us to examine what it means to detect, to interpret, and to seek meaning in the unknown. Neuroscience offers an illuminating parallel. Your brain is not a passive receiver of information. It is an active interpreter, constantly predicting, filtering, and reconstructing reality. When you hear a sudden sound or glimpse a fleeting movement in your peripheral vision, your neural circuits respond instantaneously, evaluating whether it is a threat, a resource, or a neutral event. This same principle applies on a cosmic scale. The instruments we build to detect FRBs are extensions of our sensory systems, amplified across space and time. Yet they must contend with noise, interference from our own planet, cosmic background radiation, and the intrinsic randomness of quantum events. To discern a genuine cosmic signal from this vast background is an act of cognitive heroism, a demonstration of the brain's capacity for pattern recognition, attention, and adaptation. It also illuminates a paradox. The more we refine our tools to detect subtle signals, the more we are confronted with the limits of our own understanding. Each FRB we detect simultaneously expands and challenges our model of the universe. Let us dwell for a moment on adaptation, a core principle in both neuroscience and evolution. Your brain evolved to detect anomalies in its environment because those anomalies often signal opportunities or threats. A rustle in the bush could indicate a predator. A strange sound in the night could indicate danger. Similarly, scientists have adapted their techniques to detect fleeting cosmic events because these anomalies, rare as they are, carry enormous informational value. Neuroplasticity, the brain's ability to rewire itself in response to experience, mirrors the adaptive strategies we employ in observational astronomy. Just as your neurons reorganize to strengthen critical pathways, we enhance our telescopic arrays, refine our algorithms, and improve our computational methods to maximize sensitivity to signals like FRBs. In both cases, adaptation is not optional. It is a fundamental requirement for survival and discovery. The FRB phenomenon also raises profound questions about perception and scale. How do we comprehend events that unfold in milliseconds, yet convey energy beyond anything we can imagine? How do we relate to occurrences that are both temporally brief and spatially vast? Human perception is inherently limited. We cannot directly perceive electromagnetic waves outside the visible spectrum, nor can we intuitively grasp the distances between galaxies. Yet by leveraging instruments and mathematics, we extend our perceptual reach. In this sense, every detection of an FRB is a triumph of the human mind, a testament to our ability to translate raw data into meaningful patterns. It reminds us that reality as we experience it is always mediated by our cognitive apparatus, and that there are truths in the universe that exist independently of our perception, waiting for the right conditions and tools to be revealed. There is a neurological twist here, a subtle insight into human cognition that parallels the mystery of FRBs. When your brain encounters the unfamiliar or inexplicable, it often generates a stress response. Heart rate increases, attention sharpens, and neurochemical systems flood the synapses to heighten awareness. This reaction is not a flaw, it is protective. Your brain interprets unpredictability as potential threat and primes the body to respond. Yet in doing so, it also opens the door to curiosity. The very moment your mind perceives something as mysterious, your neural systems are most receptive to learning, to pattern recognition, to insight. In other words, what initially feels like confusion or uncertainty is often the optimal state for discovery. Just as astronomers are compelled to investigate the perplexing FRB, your brain thrives in the space between known and unknown, between expectation and anomaly. There is also a quantum metaphor embedded in this cosmic puzzle. At the subatomic level, particles exist in states of probability, only collapsing into specific outcomes when observed. In a similar sense, the meaning of a signal, whether natural, artificial, or something entirely unanticipated, remains in superposition until it is detected, analyzed, and interpreted. Each FRB is an instance of cosmic probability manifesting in our instruments, collapsing from potential into measurable reality. Your brain, too, functions in this probabilistic domain, constantly weighing multiple hypotheses, predicting outcomes, and updating beliefs in real time. Perception is, fundamentally, a quantum-like negotiation between expectation and sensory input, between what we anticipate and what the universe presents. In this framework, an FRB is not merely a burst of radio waves. It is a dialogue between cosmic events and the cognitive systems capable of perceiving them. The philosophical implications extend even further. If an FRB were artificial, sent by a civilization light years away, what would that imply about consciousness and communication? Could intelligence be a universal phenomenon, emerging wherever energy flows through complex systems capable of feedback and adaptation? Even if the signals are entirely natural, they challenge our anthropocentric worldview, reminding us that the universe operates on scales and timescales that dwarf human existence. Our own fleeting moments, our experiences of life and thought, are brief blips compared to cosmic timelines. Yet, paradoxically, these signals suggest that even brief, transient phenomena can carry profound informational weight. The universe, in a sense, is whispering to us, and we are learning to listen. Let us return to the biological metaphor. The human body is a network of energy flows, a system in which signals, neuronal, hormonal, and electromagnetic, constantly interact to maintain homeostasis. Just as a neuron's action potential propagates along an axon, FRBs propagate across the intergalactic medium, shaped by magnetic fields, plasma clouds, and the expansion of space itself. Each FRB encodes information about its journey, just as each spike of neural activity encodes information about your interaction with the environment. The act of detecting and interpreting these bursts is analogous to decoding the messages within your own nervous system. It requires careful attention, computational power, and interpretive frameworks grounded in empirical science. There is also an unexpected twist in how these signals intersect with psychology. Humans are pattern-seeking organisms. When we encounter randomness, our brains instinctively attempt to impose structure, sometimes creating illusions or false correlations. The FRB phenomenon challenges us to balance this tendency. We must remain vigilant against cognitive biases while remaining open to genuine anomalies. Here lies a subtle lesson in humility. The universe is not obliged to conform to our expectations. Signals that defy immediate explanation are invitations to expand our cognitive models, to refine our instruments, and to rethink assumptions. They remind us that intelligence, whether biological or artificial, thrives not in certainty, but in the ongoing negotiation with uncertainty. And yet there is hope and inspiration embedded in this challenge. The detection of FRBs demonstrates the power of collective human endeavor, of global networks of observatories and interdisciplinary collaboration. Astronomers, physicists, engineers, computer scientists, and even philosophers contribute to the decoding of these ephemeral bursts. This is a model for the brain itself, which relies on interconnected neural networks to process, integrate, and act upon complex information. When we look outward into space, we are also looking inward into the architecture of cognition, recognizing parallels between cosmic and neural information systems. The universe communicates in signals, patterns, and probabilities. The brain interprets, predicts, and adapts. Both systems thrive on uncertainty, and both expand their boundaries when confronted with anomalies. Consider a scenario. An FRB is detected, repeated in a pattern that defies known astrophysical processes. Your initial reaction might be incredulity, perhaps even skepticism. But this is exactly the cognitive moment when adaptation and learning are most potent. Just as your neurons become more plastic when exposed to novel stimuli, scientists refine hypotheses, test models, and develop new instruments. What initially appeared as incomprehensible transforms into insight. In this way, the mysterious cosmic signal functions as both challenge and teacher, forcing the expansion of knowledge and the recalibration of expectation. In neuroscience, this is akin to metaplasticity, the plasticity of plasticity, where the brain not only changes but becomes better at changing. FRBs, in their enigmatic brevity, are exercises in universal metaplasticity, pushing our observational and conceptual systems to evolve. There is also a subtle interplay between energy and information here. An FRB is a concentrated release of electromagnetic energy, yet its significance lies not in the energy itself, but in the information it encodes about astrophysical conditions, magnetic fields, and possibly even unknown phenomena. Similarly, human thought is a flow of energy that becomes meaningful only when structured into patterns, perceptions, concepts, memories, and insights. In both cases, energy becomes relevant only when it conveys information across a medium capable of detection and interpretation. This underscores a philosophical point. The universe may be indifferent, but intelligent systems, brains, observatories, civilizations imbue energy with meaning, transforming raw signals into understanding. And now the most striking twist emerges. Often, the very complexity and unpredictability of the universe signals we cannot immediately decipher are what protect us cognitively. When your brain encounters ambiguity, it activates problem-solving networks, heightens vigilance, and engages learning systems. Similarly, the apparent randomness of FRBs may prevent premature conclusions, forcing the scientific community to maintain rigor, skepticism, and patience. What appears as incomprehensible or even threatening is, in fact, a mechanism for cognitive and collective protection, ensuring that our conclusions are robust and that insights are deeply grounded in observation and reason. The universe, in this sense, is simultaneously mysterious and pedagogical, challenging us to develop adaptive intelligence. Ultimately, what does this mean for us, for our understanding of mind, cosmos, and the delicate interplay between the two. The detection of a mysterious signal from space is not merely an astronomical curiosity. It is an invitation to contemplate the nature of reality, perception, and consciousness. It asks us to consider the possibility that intelligence, observation, and adaptation are woven into the very fabric of existence. It challenges our anthropocentric assumptions, reminding us that we are observers within an immense probabilistic cosmos and that every act of perception, whether of a fleeting thought, a neuron firing, or a burst of cosmic energy, is a bridge between known and unknown, between experience and understanding. As we gaze at the instruments that capture these fleeting bursts, and as we ponder our own neural systems, one question emerges. If a signal from billions of light years away can reach us, altering our understanding of physics, biology, and cognition, what other truths lie hidden, waiting for a receptive mind to detect them? The answer may not arrive in the next millisecond or even the next century, but the act of listening, interpreting, and adapting is itself a fundamental form of engagement with the universe. In this sense, every discovery, every fleeting insight, is a form of cosmic resonance, a dialogue across scales, from neuron to galaxy, from mind to cosmos. So, the next time you consider the limits of your own perception or the boundaries of human understanding, remember the mysterious signal from space. It is a reminder that uncertainty is not an obstacle but a gateway, that the unknown is not a threat but an invitation, and that intelligence, whether in neurons or telescopes, thrives on the interplay between expectation and discovery. The universe is not silent. It is filled with whispers, pulses, and bursts, each carrying potential insight, each beckoning us to listen more deeply. And as we listen, we grow not only in knowledge, but in the capacity to wonder, to adapt, and to recognize that our minds, like the cosmos itself, are dynamic, evolving systems engaged in an endless dialogue with the unknown. If this exploration sparked your curiosity and left you questioning the very nature of perception, space, and the mind, join the conversation. Share your thoughts in the comments, explore the questions that arise in your own reflections, and consider subscribing to MindSpark Science for more journeys into the mysteries that lie at the intersection of neuroscience, physics, and philosophy. Together we can continue to follow the signals, whether they come from the neurons within our brains or the stars across the cosmos, and uncover the profound insights that await those who dare to listen.